In this video, we will learn about useReducer for more complex state logic. First, we will understand what is useReducer. UseReducer is a React hook for managing state transition based on explicit actions. It centralizes updates inside a reducer function instead of scattering set state calls throughout your component. This is the signature. Here, state is the current state snapshot. Dispatch action triggers a state transition. Reducer state action is a pure function returning the next state. When to prefer it? When state transitions are non-trivial, multiple fields, branching rules, whenever you depend on the previous state in a nonce ways, when you want explicit testable state transitions, and whenever you are moving toward a context-based shared state. Now we will see an example of minimal counter. First, we will import React and useReducer hook. UseReducer is an alternative to useState for managing complex state logic, especially when updates depends on the previous state or have multiple actions. Next, we define a TypeScript type called state that describes our state structure. Here, our state is an object with one property, count, which is a number, example count 0. After this, we define another type called action representing all possible actions that can modify our state. There are three possible actions. Type increment, it increases count by 1. Type decrement, decreases count by 1. Type set, payload number, this sets count to a specific number. The union type ensures that only these actions are allowed. Next, we define the initial state of our counter. When the app starts, the count is initialized to 0. And this is the reducer function, the core logic of our app. It takes two arguments. State, this is the current state. Action, this is what we want to do. Then it returns a new state depending on the action type. First case is increment. It increases count by 1. Example, count is 0 first. Then it will increment to count 1. In decrement, it decreases the count by 1. That is, the count was 1. Now it decreases to count 0. Third case is set, which directly sets the count to a value provided in action payload. For example, count 5 plus type set payload 10. Now the count is 10. If an unknown action type is dispatched, the default case simply returns the current state unchanged. Now export the default function counter reducer. We define our main component named counter reducer, which will be displayed in UI. Next, we call the useReducer hook with the reducer function and the initial state. UseReducer returns an array with two elements. First one is state, the current state value, that is count. Next is dispatch, a function to send actions to the reducer. Whenever you call dispatch, React executes the reducer function and updates the component. Here is what this JSX does. When first button is clicked, it dispatches that type increment, which increases the count by 1. When second button is clicked, it dispatches decrement, which decreases the count by 1. When the third button is clicked, it dispatches type set payload, setting the count directly to the. This is the simple counter interface with the 3 buttons. As you can see, we have 3 buttons. When you click the first button, it increments. On the second button, it decrements. On the third button, it sets the value to the 10. Key points you must know are actions are discriminated union for safe type dispatches. Reducer is a pure, no side effects, returns new state. Next, we will see one more example form with validation using useReducer. This is a registration form with name, email, password, inline validation and submit handling. We start by importing React and useReducer hook. useReducer helps manage complex component state logic, especially when multiple related values are updated together. Think of it as a more powerful alternative to useState. Now we will define the form state type. This defines the structure of our form state using TypeScript. Name, email and password store user input values. Error, an object that can hold error messages for these fields, submitting a boolean that becomes true when the form is being submitted. So our form state might look like name John, email john@gmail.com, password 123456, errors in the curly braces which can store the errors of these fields, finally submitting. Next we will define the action type. Here we define all possible actions that can happen in our form. Change user types in a field, validate. Form inputs are checked for errors. Submit. User submits the form. Success, registration succeeded. Failure, submission failed. Reset. Clear form data after success. Each action triggers a state change handled by our reducer function. This is the initial form state. This is the starting point. Empty input fields, no errors and not submitting it. Next, validation function. This function checks for the invalid inputs. Missing name, error shown below name field. Missing at in the email, invalid email. Password less than 6 characters. Short password error. Next, the reducer function. This function receives two things, the current state and the dispatched action. It returns a new update state depending on the action type. First is the handling input changes. When the user types in any input, this updates only that specific field while keeping the rest of the state unchanged. Next is validation form. This runs the validate function and updates the error object in the state. After this, we go to the submitting form. This sets the submitting to true, useful for disabling the button and showing a loading message. Next is success case. Once registration succeeds, we mark submission as complete. Failure case. If validation or API fails, we store the error messages and reset submitting to false. Reset state. It resets the form to its original empty state. Default case. In case an unknown action is dispatched, keep the state unchanged. Now coming to the main component, that is registration form with useReducer. We call useReducer with our reducer function and initial state. It returns two things. State, the current form state. Dispatch, the function used to send actions like change, validate, submit. Handling input changes. Whenever the user types into any input field, this function dispatches a change action updating that field's value in the state. Now handling the form submission. When the user clicks register, we first prevent page refresh and dispatch a validate action. Validation check. If errors exist, we dispatch a failure and show the validation errors immediately under each field. Now simulate API call. The submit action sets submitting to true. We simulate an API call, a fake 600 millisecond delay. Once it's done, we log the register data into the console, then dispatch success and finally reset to the clear form. Handle the server error. If something goes wrong, example API fails, an error message is displayed below the email field. JSX output. This displays a text box for name, and if there is an error, it shows a red error message. Same pattern continues for email and password fields. Finally, the submit button. Once submission completes, it reveals to register. This is the output. Name input field, email input field, password, register button. When clicking the register with empty inputs, name is required. Invalid email address, password must be at least 6 characters. When valid details are entered, the button text changes to submitting. After 600 millisecond console logs, registered name alias, email alias at gmail.com, password 123456. The form clears automatically after submission. Summary. useReducer manages form state transitions clearly. Each user action triggers a specific update. Validation, submission, and resetting all controlled using useReducer logic. This demonstrates a centralized updates and validation with a single reducer. Clear action types for changes, validation, submit, success, failure, and reset. A pattern ready for unit tests. Reducer can be tested in isolation. Next, useReducer versus useState. How to choose between these two? When to prefer useState? State is simple and localized, a few fields, minimal branching. Updates are straightforward. When to prefer useReducer? Multiple related fields that change together, complex transitions or validation rules. You need a single testable control point for all updates. You plan to share a state via context. Let's see an example of shared state across tree. Let's start by importing three important hooks from React: create, context, use context, and useReducer. We define a type called setting state which describes our app settings. It includes two properties: theme, which can be either light or dark, and compact, which is the boolean value. Next, we define a type called settings action. This represents all possible actions we can perform on our settings. It includes three action types: toggle theme, it switches between light and dark mode. Next is set theme, it sets a specific theme. Next is toggle compact, turns the compact mode on or off. We now create a context called setting context using the create context. This context will hold our state and dispatch functions so that any component in the app can access or modify settings. Initially, the context is set to null, meaning it must be provided later using a provider. Next, we define our initial setting state. The default theme is light and compact mode is set to false. Then we create our settings reducer function. It takes the current state and action and returns a new state based on the action type. In the first case, if the action type is toggle theme, we switch this theme. If it's light, we change it to the dark. Otherwise, we change it back to the light. In the second case, set theme, we directly update the theme based on the action's payload value. In third case, toggle compact, we flip the value of compact mode between true and false. If none of these cases match, we return the existing state by default. Now comes the settings provider component. This is the provider of our context. Inside it, we call the useReducer hook passing in the reducer function and our initial state. This gives us two things, state to hold the current settings and dispatch to trigger actions. We wrap our children components inside the settings context provider, passing in the state and dispatch as its value. This means every component inside the provider can now access the settings and change them when needed. Next, we create a custom hook called useSettings. This hook allows any component to easily access the context without repeating the useContext logic. We first get the context value using the useContextSettings context. If there is no context available, meaning the hook is used outside the provider, we throw an error for safety. Finally, we return the context object which contains both state and dispatch. In the comments at the end, we can see an example of how to use this in another component. We simply call useSettings to get the current state and dispatch function and then dispatch an action like toggle compact to update settings dynamically. This is the output. Before any interaction, theme is light, compact is false. When you dispatch, that is type toggle theme, the theme switches from light to dark or vice versa. When you dispatch type set theme payload dark, the theme directly becomes dark regardless of its previous value. When you dispatch type toggle compact, the compact setting flips from false to true or from true to false. What the user sees in the UI depends on how you render this state. For example, if component displays state theme, it will show current theme dark when dark mode is enabled. This all matters because composable pattern for app-wide preferences keeps reducer logic testable and calculated. Some of the common pitfalls and tips are: do not mutate state in the reducer. Always return a new object or array. Reducer must be pure. Avoid async or side effects inside the reducer. Use effects in the components or middleware like helpers. Keep action specific and type discriminated union prevented invalid